write in electron dot notation or electron dot formula, we're just going to look at the orbital notation, find this highest energy level, and we'll know it's the highest energy level because it has this big coefficient 2. There might just be one coefficient 2 here, as there is here in beryllium, or there might be two of those, as there is in fluorine, but all together it makes up the valence level. That's a term you need to know, valence level, or valence electrons. Both of those terms are used, and both of those are valid depending on what you're talking about. If you're talking about it all together, you're talking about the energy level in which these electrons are found. If you're talking about valence electrons, you're talking about the individual electrons. Okay? So all of these electrons make up the valence level. All of these electrons make up the valence level. And when we're writing electron dot notation or electron dot formulas, we want all of those electrons included. So let's do beryllium first, and I'll show you how that works. Then we'll do fluorine. Okay? So here's beryllium. You're just going to write the symbol for beryllium. Okay? You're going to count the number of electrons in that highest energy level called the valence level. And you're going to put dots around the element symbol, one on each of the four sides. Imagine there is a square drawn around this. You're going to put the dots where the edge of the square is, not at the corners. Okay? So you just count the number of electrons and put one on each of the four sides until you're done. Okay? 1, 2, and there's beryllium. Okay? Well, the reason I'm telling it to you this way is some teachers teach you to put the two dots together. Don't do that in here. Okay? Just in case. Okay, remember just in case? Yeah? Guy who sells insurance or... Okay, never mind. All right. Let's go to fluorine then. Here's fluorine. How many electron dots do I need for that? 2, 4, 6, 7 electrons. So here's how that works. One on each of the four sides. And then, after you put one on each of the four sides, you can pair up what is needed. Now, you only pair them up. You can't put 3 on a side or 4 on a side. Okay, and I have people on tests that'll put, let's see, fluorine has a total of how many electrons total? I don't have my periodic table here in front of me. 7? No, it has 9 total electrons. They'll put 9 electrons around this thing. You don't do that. It's only the valence level electrons. Only those in the highest energy level are used in this electron dot notation or electron dot formula. Okay? So I have 4 now, and I can pair them up on any of the 4 sides I want to. Doesn't matter whether I put them on the top, bottom, or either one of the 2 sides. Okay? Here's 1, 2, 3. There's 7 electron dots, and that's the electron dot formula for fluorine. Okay, but I could have this single dot at the top, at the bottom, on the side, whatever. Everybody with me? Do you understand? All right. So now I want you to write the electron dot notation for aluminum. Write the electron dot notation for aluminum. I'll give you a minute to do it. You can share. All right, restarting the video here. Make sure you pause the video and try this for yourself before you watch me do it. Here is aluminum's symbol, Al, and by the way, in Britain and most of the rest of the world, they pronounce it not aluminum, but aluminium. Okay, so I've got aluminum down here. And I look at the highest energy level, and that's 3. And the electrons, total electrons in 3 are 1, 2, 3. In this particular case, 3 happens to be 3. So I need 3 dots. 1, 2, 3. And I'm done. Got that? That's not so bad. Got it? All right. You want to try one more? One more before I give you a homework problem on this?
Yes.
Let's see. One we did yesterday. Now remember, here this is kind of a tricky one, okay? Remember, it's only the highest energy level electrons. You with me? Only the highest energy level electrons, yes? Okay. Scandium. Do an electron dot formula for scandium. Yeah. All right, let me see how you're doing with scandium here, okay? So here's the orbital notation for scandium. How many electrons in the highest energy level? Just 2. Okay, you can't count the 3 because the 3 isn't included. So scandium just has 2 electrons, and we do this. Okay, now, in reality, this is the problem with those transition metals. Remember that scandium is in the transition metal area? Okay, it's in this section right here, the transition metals. And those don't always behave the way we'd like them to. In fact, there's some over here that don't behave quite like we want them to, okay? It'd be nice if they were more, easier to follow, but it didn't work out that way, so we have to work with what we got. Scandium actually probably more often than not should have a third dot, but we're not going to do that in here. What? Because that's how many electrons there are in the highest energy level. 4 is the highest energy level. There are only two electrons there. This is the third energy level. That's one down. Highest energy level, 4, right? 1, 2, 3, 4, right? 4. There's the highest energy level for scandium. That's its valence level.
And it has 2. That's why we do 2 dots.
Right, I know, but he's kind of like, what? And it happens. Listen, happens to me sometimes, okay? You like, it's simple, but you don't get it. I remember in 3rd grade, I had the hardest time with those pronunciation markings in the dictionary. Couldn't get it the whole time I was in 3rd grade. Finally, in 4th grade, it made sense, but it didn't make sense at all to me in 3rd grade. Well, not the pronunciation markings, but the emphasis markings, you know, where you have to emphasize one syllable over another. Did y'all do that in 3rd grade or 4th grade? No?
I try to not remember what I did.
Oh, you try not to remember. Okay. Let me write a note here to contact your 3rd grade teacher. Okay. All right. Yes, Mark. I'm just joking. What, Mark? What? Calcium's right above it. Right. It only has 2 as well. Right. Okay. Everybody good? No.
He's fine. I told him to stop. I will let him know.
All right. You got a bunch of people around you that are willing to help you all you want. Okay. All right. Homework.
Thank you. I love homework. I definitely go home with it. The lighter. Both times.
Yes, but the full electron configuration of the kernel version. So both kinds means that. And the electron dot formulas for, let's pick something we haven't done yet. You want to do arsenic? No, we can't do arsenic. We have. Well, let's see. Well, it kind of depends, but yes. How about we do germanium? Remember on your element cube, we don't capitalize the element names because I'm trying to emphasize the fact that it's not a proper noun. You don't always capitalize those, only if it's with the first word in a sentence or something. So let's do germanium and zirconium. Okay, and we're kind of out of time, so I will check today's homework tomorrow. Okay. Yes.